Okay, so today's lesson comes from Go Math 7.7 that is titled Problem Solving Combining Like Terms. Now take a moment to read the essential question to yourself. Okay. And the essential question reads, how can you use the strategy use a model to combine like terms? So what does that tell us? That tells us that today we are in fact going to be using a problem-solving strategy, and that strategy is going to be making or using models. Like terms are terms that have the same variable with the same exponents. I think we have to box this in because this is critical and it's really important. So like terms are terms that have the same variables and the same exponents. So variables have got to be the same and exponents have got to be the same. Now, all numerical terms are also like terms. What does that really mean? That means the number 7, the number 27, the number 87, 57, 507, 662, all of those are going to be like terms. I don't know why I was just choosing a bunch of 7s there. Nonetheless, they've got some algebraic expressions in which you see like terms. The 5x, the 3y, and the 2x, of which 5x and 2y are like terms. 3y is not a like term because it doesn't have the same variable. And the next one, 8z squared plus 4z plus 12z squared. Well, which one of these things is not like the other? Well, that's actually going to be the 4z. It's not like the other terms. And that's because, very simply, it doesn't have the exponent 2 there. So those are big key components in this lesson. Now we can take a look at the rest of the table where it shows us the like terms and the ones that are unlike, but let's move on. The unlike the problem reads, baseball caps cost $9 and logo patches cost $4. Shipping is $8 per order. The expression 9n plus 4n plus 8 gives the cost in dollars of buying caps with logos for n players. What are we asked to do? We're asked to simplify the expression 9n plus 4n plus 8 by combining like terms. If you could just give me a moment, let me go ahead and take this view to normal view. Okay, so now we know we're asked to do an important thing of simplifying the expression by combining like terms. What are some important things in this actual setup of the problem? This expression right here. And so we're going to be using a graph organizer to help us organize this problem. And we know the question's asking us to, or what do I need to find? Simplify the expression, and that expression is 9n plus 4n plus 8. As we read the problem, we had to think about what information do I need to use? Well, I need to use the like terms in this expression. And what are those like terms in this particular expression? You got it, the 9n and the 4n. So 9n and 4n are like terms. How am I going to use this information? Well, I'm going to use a bar model to find the sum of, what do you think? The sum of the like terms, or the ones that are alike. Well, here's our bar model already drawn for us. We have n, a total of 9 of them to represent our 9n, and then we have another set of n's that are in green to represent our 4n's. And how many n's is it in total when we add the 9n and the 4n together? Hopefully you know that quickly is 9n. So when we look at this, we're simplifying this expression by combining the like terms of 9n and 4n, adding them together. And so that gives us a more simplified expression of 13n. And don't forget, the full expression was 9n plus 4n plus 8, so we have to include that 8 as well. So again, simplified expression for the cost in dollars is 13n plus the 8. Pretty manageable so far? Okay, let's try another problem. Paintbrushes normally cost $5 each, but they're on sale for $1 off. A paintbrush case costs $12. The expression 5p minus p plus 12 can be used to find the cost in dollars of buying P, standing for paintbrushes, on sale plus a case for them. Simplify the expression 5p minus p plus 12 by combining the like terms. So let's just underline what we have to do, and let's go ahead and circle or box in any of those important facts. And the fact that we're simplifying this expression, I think that's important as well. Well, what do we need to find? Well, we need to find a simplified expression, and it's a simplified expression for what we have here, 5p minus p plus 12. What information do I need to use? Just like the last problem, like terms. Which terms are alike? Well, I believe 5p, correct? So the 5p and p. Well, how will I use the information? I'm going to use a bar model. And that bar model is actually going to be shown slightly different this time. All right, let's go ahead and solve the problem. Well, if I'm stuck here, what I can always do is use a similar problem that I've already seen. So let's just go back. Here we had the 4n and the 9n, and we just drew out 9n in a different color. Well, in yellow it was drawn for us. And then we had 4n in the green, and we combined those together because remember it was 4n plus the 9n. Well, here it's 5p minus p. Oh man, so what are we going to do? I think I should definitely still represent 5 of these p's to represent the 5p. But in this case, what I'm going to do is I'm going to draw a bar model that's going to show. Now, what happens when I take one of those p's away? And so I'm left with how many p's left? 4p. So I'm going to draw 5p, and each square at the top, in that top row, represents a p, 5p to be exact. Second row shows taking away 1p. Now, a simplified expression is simply going to be what happens when I actually look at combining these terms and in essence solving them. So what happens when you take 1p away from 5 p's? You're left with 4p, and don't forget that we have that other term, but it's not like the 4p and, or I'm sorry, the 5p and 1p. 12, that's there. Now I'm going to go ahead and have you explain how you know the bar model shows your answer is correct. We kind of did that a little bit. And then explain how you can combine like terms without using a model on your own. Hopefully this video was helpful and not too long. And now you're going to be successful with solving the problems on your own, as well as the share and show on the next few pages.